Today, we are going to do something a little different. We're going to reverse engineer a huge 16-mark GCSE Physics exam question. We'll use the official mark scheme to see exactly what separates a good answer from a perfect one. All right, let's get into it.
It's the ultimate question, right? And the answer is, you have to learn to think like the examiner. You need to know point by point exactly what they're looking for. And that's what we're doing today. We're decoding the mark scheme to see how every single mark is won. And this is our focus. Now, it might just look like a simple graph showing the current and potential difference for a filament lamp, but hidden inside this curve and the questions that go with it are 16 potential marks. That is a massive chunk of a paper. Let's get started. So, here's the game plan. We're going to dissect question 6 from an AQA higher tier paper, piece by piece. We'll look at each part of the question, and then we'll jump straight to the mark scheme to see what a top-level answer really looks like.
First up, the big one. 6 marks just for describing a practical method. This isn't just about knowing the physics. It's about clearly communicating a complete, logical, scientific process. So what does a full 6-mark answer actually involve?
Okay, let's check out the mark scheme's indicative content. This is basically the examiner's checklist. You need some way to change the potential difference, like a variable resistor. You absolutely have to say you're measuring potential difference with a voltmeter in parallel and current with an ammeter in series. And crucially, for this specific graph, you have to explain how to get those negative values by flipping the connections on the power supply.
You know, the mark scheme is incredibly specific about the circuit diagram. The placement of the ammeter and voltmeter, that's non-negotiable. You also have to mention how you'll vary the potential difference. And hey, if you really want to push your answer into that top band, adding little details like taking repeat readings and calculating a mean, that shows you really know your stuff when it comes to experiments.
And boom, here it is. This quote from the mark scheme tells you everything. To get into that top level, level 3, you must have a circuit that works, and you must explain how to get those negative values. If you miss that second part, you literally cannot get full marks, no matter how great the rest of your answer is. The lesson? Read the graph and make sure your method accounts for everything you see.
All right, let's switch gears. We're moving on from the practical setup to the pure calculations. This is where we'll be using both the graph and our trusty physics equations. Okay, question 6.2, a 3-mark calculation. It seems pretty straightforward, right? But the first mark is actually hidden in the graph itself. This question is testing if you can pull the data correctly before you even think about picking up your calculator. So first things first, use the graph. You go along the horizontal axis to 3.0 volts, then you track straight up to the curve and read across to the vertical axis. You can see it lands a little bit above that 0.15 amp line. The mark scheme confirms the correct value is 0.16 amps. Nailing that reading is your first mark. Once you have your values, the rest is just method. State the equation you're using, R equals V divided by I. Then, plug in your numbers, 3.0 divided by 0.16. That gives you a final answer of 18.75 ohms. You get 1 mark for the right substitution and 1 for the correct final answer. And just like that, 3 marks are in the bag. Next, a hefty 5-mark question. This is a multi-step calculation, and it's all about energy transfer. Now notice, they give you the current and voltage, so you don't need the graph this time. But there's a classic trap right there in the question, 30 minutes. You gotta remember, physics calculations need standard units, so our very first job is to convert that to seconds. And here's where knowing the mark scheme is a total game changer. It actually shows there isn't just one single way to get the right answer. Examiners will give you credit for any valid physics. Let's take a look at the first method they list.
So, method 1 uses the equation linking energy, charge, and potential difference. First, you convert 30 minutes into 1800 seconds. That's your first mark, right there. Then you calculate the total charge that's flowed using Q equals I times T. So that's 0.21 amps times 1800 seconds, which gives you 378 coulombs. Finally, you calculate the energy, E equals Q times V. 378 coulombs times 6 volts gives you the final answer, 2,268 joules. But hey, what if that charge flow equation doesn't pop into your head during the exam? Well, no worries. The mark scheme provides a second, equally correct way to do it, and this one starts with power. With this method, you first figure out the power of the lamp using P equals I times V. That's 0.21 times 6.0, which is 1.26 watts. You still have to do that time conversion to get 1800 seconds. Then you just use the energy transfer equation, E equals P times T. So 1.26 watts times 1800 seconds. And look at that, it gets you to the exact same answer, 2,268 joules. The takeaway here is that multiple paths can lead to full marks, as long as your physics is solid.
Okay, so we've tackled the method and we've crunched the numbers. This final part of the question tests your conceptual understanding. It's all about explaining why the physics works the way it does, using that graph as your proof.
So here's the scenario. A student makes a prediction, probably based on a simple proportionality rule they remember. But we know from that curve on the graph that the relationship isn't that simple. Your job for 2 marks is to explain why the student's prediction is wrong.
And just like with the last calculation, the mark scheme actually gives you 2 different ways to get these 2 marks. Path 1 is all about resistance. You'd say that for power to go up by 4 times, both the current and the potential difference would have to double. But that doesn't happen, because the lamp's resistance increases as it gets hotter, which stops the current from doubling. Path 2 focuses on proportionality. You'd start the same way, but then you just use the graph as your evidence, pointing out that the curve clearly shows that current is not proportional to potential difference. Both are perfect answers.
So, there you have it. We have completely deconstructed a 16-mark question. By looking through the examiner's eyes, using the mark scheme, we've seen exactly what's needed for every single point.
Think about all the skills this one question covered. We've gone from practical design and circuit diagrams to reading graphs, doing multi-step calculations, and explaining some pretty complex relationships. But honestly, the biggest skill we've unlocked is understanding how a top-tier answer is structured and knowing exactly what details earn the marks. That, right there, is the real key to success.
And that leaves us with one final thought. We've seen the 6-mark method, the 3- and 5-mark calculations, and the 2-mark explanation. Now that you've seen what the examiners are actually looking for, which part seems most straightforward to you? And which one do you think would still need the most practice? Thinking about that is the first step to mastering them all.